First off, thanks for coming, everybody. Welcome to ShopKeep. I just want to say that we've been running the Continuous Delivery NYC Meetup here for about 1.5 years, and we're always looking for speakers. So if you have a story to tell, particularly about how you're either already doing continuous delivery or on a journey towards continuous integration, any one of these technologies that would be of interest to everyone, please come meet up with me either after the talk, shoot me an email, send me a message on Meetup. Happy to help you, bring your message to the world. One of the things about why we support this meetup here at ShopKeep is that we find that the best way to learn is by learning from people who've already done it, right? You can read any blog you want. You can, read some dry piece of documentation, and that will help you when it comes time to actually troubleshoot your problems. But if you really want to hear real world examples of how people have solved similar problems to yours, this is the best way to do it. And the even best way is to then take what you've done, show it to the world, have people question you and ask you, because then you're going to think of new ways to make your system even better. So again, please come speak at the meetup if you're interested. And with that, I'm going to turn it over to the Lyft deploys team. We have Garrett and Jan here to take us through what they're doing. So warm round of applause for these guys.
Hi, everyone. My name is Garrett. I work at Lyft on the deploys team, and this is Jan. We're visiting from SF, so we made sure we included a nice photo of New York for you all. So yeah, today we're here to talk about sidecars. And before we start to talk about that, I'm going to give you an idea of sort of what infrastructure looks like at Lyft currently. And to do that, I'm going to go through what our infrastructure looks like, how we configure things, how people deploy things and what deployments look like, and also some of the challenges that we have today.
Yeah, and I'm going to talk a little bit about our future direction. So we are, spoiler alert, moving to Kubernetes. So talk a little about the infrastructure that lives in. Some of the expectations people have gathered at Lyft over multiple years of how things work. And then a couple of the steps and then future direction we're taking with this technology stack.
Okay, so current state. So today, infrastructure at Lyft, we're hosted primarily on AWS, and we're in 3 availability zones. We do that for reliability. We run about 400 services, and they range in importance. And we run about 20,000 EC2 instances for normal Lyft operations, give or take. And we run in a single tenant model, so we have 1 service on each host. We really, really heavily leverage Envoy as a service mesh here at Lyft. If you haven't heard about Envoy before, it's an open source proxy that originated at Lyft. And the great thing about Envoy is it gives us a lot of stuff for free. So it gives us service discovery, observability, circuit breaking, load shedding, and a bunch of other stuff. So as you can see by the diagram here, we run Envoy actually in 2 configurations. We run it as an edge proxy. So every time your phone connects to Lyft, it's hitting an Envoy instance first. It's then being routed into the mesh network. And then between the mesh, each service talks out through a local Envoy sidecar that lives on the host. We also run things like Confidant, which is another project we have for getting credentials, and a number of other things as in a sort of sidecar model on each host. Configuration at Lyft has a few different parts. So we run a masterless salt configuration. I don't know how many people here use salts. It's maybe not one of the most commonly used configuration management languages these days, but we use it for 2 different things. We use it, to provision resources in AWS. So we use it to create all our auto scaling groups. This is an example on the left that would be very common in a team's repository. They'll say, I need this auto scaling group to create my cluster for my instances. And we also use Salt to manage the software that we install on hosts. So the example on the right is what a typical Go service might do to get up and running. They might pick the version that they're running. They may configure some circuit breakers and things like that. And another thing we have for configuration is actually a manifest. So as we started to grow, we realized that we needed to capture some more metadata about all of the services that we run. So we have this thing called a manifest to do that. And it's called manifest.yaml, lives in the root of each repo. It looks something like this. This is a manifest from a service that I wrote a long time ago. And it's a declarative structure, and it captures a bunch of different things about what the service does. Captures things like who's on call for this, what kind of tests, how do deployments work, what tier does this sit in, is this critical to Lyft's operations, or could it go down for a week and nobody would notice? So we captured all of that in the manifest. And today, the manifest applies mostly to dev and test, but not to production. And that's mostly an artifact of the fact that we created the manifest a little bit later on when we realized we had this need to create developer tools and things around all of the services. So we didn't sort of start with the manifest. It's something that organically grew as we grew as a company. And this kind of gives an idea of what the layering looks like for configuration today. At the very bottom in development, we have a Docker file. So we did start to go into containers. A couple of years ago, we got on the bandwagon. We have Docker files for orchestration, and we use containers locally in development. So we'll call into Salt with the Docker files that we have in development, and we use it for caching and a few other small things.
Hey, we're going to take a 10-second break while we just switch to broadcasting this presentation on Hangouts so the guys downstairs get a better view. So give us 1 second. Yeah, you know the link? What's that? CDNYC, yeah.
Is it an actual hangout?
He's gonna, yeah, it's an actual hangout. Okay. Oh, do you want me to just invite you to it? He was gonna give you a link.
Or link works. I don't know how he's gonna give me a link, but email works.
What's your email address?
YRAMIN. RAMIN. Lyft.com.
Yep. I just added him to it. But if you know the link, we could just type it in.
Yeah.
It's not just hangouts.google.com/shopkeep/.
So they have to be like on the. It's an external account that we have to invite it.
Can you guys see it downstairs? Hey, Jetin. Jetin, is he sharing the screen? Can you see it? Yeah, we're getting thumbs up. Perfect. Sorry about that. Back to our regularly scheduled program.
Okay, thanks for being patient there. So yeah, as I was saying, we run a Docker file locally for containers. And then on top of that, we have this layer called base, which is what the infrastructure team at Lyft manages. That's the greater team that I'm on. And in base, we stick all the sidecars, so things like Envoy, a bunch of different daemons for doing things like logging, stats, as well as language archetypes. So what it looks like to be a normal Python or Go or Java service at Lyft is embedded in our base layer. And that means that services or teams don't have to recreate all of that every single time that they want to spin up a new service. It also means that we can update things very quickly and do it for everybody in one fell swoop. And then on top of that base level that infrastructure owns, services will have their own Salt configuration. And so in there, they'll stick their own infrastructure. So the auto scaling groups, the DynamoDB tables, as well as any extra dependencies. Maybe they need some libraries, as well as other customizations, things like the circuit breaking settings that you saw just before. And just to reiterate, containers are only used in development right now. And I'll talk a little bit more about that as well. So we still don't use containers in production, and that's a question that people might say, like, why don't you use them? You should be using them. It's 2018. Well, we really want to use containers in production, and we tried to use them 2 years ago, and we ran into a number of issues. And the biggest of them are up here. Networking limitations were one of the issues that we ran into. We found that there was too much overhead with the bridge network, and we didn't want to compromise isolation with a host network. We looked at the container orchestration systems that existed at the time, and we found that they were immature, or nobody had really settled on a specific one. So we would have had to do a lot of work to kind of get to a point where we felt comfortable running with one of them. And we ran Docker in development for a while locally. We have a system called OneBox where a Lyft engineer can essentially run a version of Lyft on AWS. We run them on big, beefy R4 4x larges because they use a ton of RAM. And we started using Docker here really early, but we found that the Docker daemon would just crash randomly. I'll remind you, this was 2 years ago, and so things may have gotten better, but we had a lot of issues with it where we didn't feel comfortable necessarily going straight to production. And this may sound a little cliche, but we're growing a lot as a company too, and we still had a pretty small infrastructure team. So whilst none of these were really huge issues, we probably could have overcome each of them. We didn't have the resources to go and spend a bunch of time operationalizing things. So we had to focus on some short-term reliability things instead of maybe making a longer-term bet on Docker or containers at the time. So yeah, on a more positive note, back to deployments. So at Lyft, we do about 200 or so deployments a day. It varies. Sometimes it's code, sometimes it's configuration. And we utilize the pull model for deployments. So this diagram up here kind of gives a simple view of what happens. Every single host in AWS is polling S3 on a 60-second polling interval. And it's basically just asking, is there a new version that I need to pull down and deploy? So this has scaled incredibly well. We have not changed this very much in a number of years. We've 10 times, more than 10 times the number of instances without any real issues. S3's held up really well. And what happens when the artifacts are pulled down onto the host is that we have a script that's written in Python, and we call it pull deploy, that unpacks the artifacts and then hot restarts the services that are running, as well as run salts to do some other updates. So we try to bring the host into a consistent state with whatever that deploy says. And it's also worth pointing out that the base and service are separate artifacts. So you saw earlier that we have something called base that infrastructure manages, and service, which each service will have their own. These are independent and can be deployed independently. And coming along with a base deployment, it's something that is quite scary, although also quite powerful today. We do them once or twice a week. We generally are very careful about doing them. It lets us do things like upgrade our version of Envoy across the entire fleet in like 15, 20 minutes. So it can be really, really powerful, but it can also be really, really scary because Envoy, as you saw before, is used in every single request like 20 different times. So if there's an issue with Envoy, if there's a memory leak or something like that, we have the potential to really cause pretty catastrophic damage. So we maintain a healthy dose of fear with these, and there can be some unexpected things that can go wrong if you do the wrong thing with one of these. And this is what a deployment looks like to a Lyft engineer. It's a Jenkins pipeline. It's pretty simple. Again, it's scaled pretty well. It's starting to show its age now as we've grown as a company. But each of these stages is basically a staged way of getting to production. So we have a staging environment. It's used very heavily. We have Canary, which for us is a single production host. And we segment it off so we get stats and logs and things individually for that. And we have per AZ, or availability zone deployment, so we can deploy to 1/3 of all of our production hosts, or potentially 2/3 before we go all the way out to production. And we call it baking, which means like stay on one of these environments for some period of time until you're confident that your change did the right thing. That's usually somewhere between like 8 minutes and maybe even an hour if you want to be really safe. And yeah, we really encourage people to bake their changes on one of these stages to make sure that they're seeing the intended effect before they move on. So yeah, I've just told you a lot about the stuff that we have right now, and there are a lot of challenges that we have with this, which is kind of why we're looking at changing some of this up. The biggest of these challenges is that mutating hosts just leads things to get into an inconsistent state. It happens all the time. It's really hard when you're updating, you're hot restarting things, you're updating things in place. There will be drifts, and it requires incredible care to do this correctly. A good example of where this can go wrong is there are a bunch of scripts that we have that live in base, where if you make any change, you add like a space, it'll trigger a fleet-wide restart to everything. And sometimes it's really subtle, or you may not know this is going to happen. Nothing tells you like, don't do this. And you may just like take down every service for 10 seconds, which maybe doesn't sound like long, but it can have pretty bad effects. So this leads to a lot of issues, and it's something that we've had to be really, really careful of. We have decentralized resource definition in the sense that every team owns their own salt states for auto-scaling groups and things like this. And that's great. It lets them move really fast and do whatever they want, more or less. But it has led to a lot of copy and paste and a lot of redundant or duplicated things. And it makes it really difficult to roll out fleet-wide changes. So, one of the things we're doing right now is upgrading instance types in AWS, moving to C5. And it means that we have to deploy and change 400 services to actually make that change. So I'm the person doing that. It's very, very painful. I don't recommend anyone ever have to do that. One of the other issues is that we have too many different places to configure things for service owners, and it's quite verbose. So you heard me talk about manifests, Docker files, salt states, and so on. It's really confusing for a service engineer to just want to write some code and they don't know the thing that they have to update, because all of these things, it may be in one of these places they don't know right off the bat. And this is just kind of a thing that has naturally emerged as we've grown. We add a new thing to sort of take care of a new need. And so we've ended up in a state where we have multiple things. And then kind of leads me to being halfway in on containers has not worked really well for us. We have environment drift between development and production because we have a Docker file that only applies in dev, but production is not using containers at all. So that means if an engineer puts, they install a dependency in their Docker file, they will be sometimes surprised to find that that doesn't exist in production, and things may go wrong. And we also want a lot of things from containers. We use Python a lot, and we want to bake virtual environments into containers so that we don't have to depend on the general internet being good when we want to launch a host. So that's something we identified pretty quickly we need to fix after having some issues. And we can't just bake them into containers or into images, I should say. We have to basically write our own salt magic to make that happen. And it's really, really complex. It has a bunch of edge cases. And we've just kind of had to put up with that because we're not using containers in production still. So now Jan is going to talk about the road ahead.
Thank you. Hi. I'm going to talk about the road ahead, as Garrett just said. So we're kind of in the middle of an infrastructure transition. We are toe in the water on Kubernetes. We've definitely committed to the fact that we want to use containers in production. We've done a lot of development from kind of a very basic infrastructure point to get us there, and I'll talk a little bit about how our setup and everything in that space works. Realistically, though, we need to get our containers and our normal production environment into a consistent place. We can't just go turn off one and boot the other and hope everything's fine, because then Lyft will not work for some period of time while we sort that out. We need to be able to boot the old hosts, run Kubernetes, pretend they're one and the same. Envoy obviously helps us here. It's kind of our service mesh routing system. But for Envoy to work, we need to treat Kubernetes as everything is consistent. The pod looks like another host, as it should in the model. One thing Garrett kind of brushed on is like we have a lot of places to configure things. Our initial goals, predating even me being at Lyft, for our developer infrastructure, DevOps in the time, was to really drive a platform as a service. This is all the archetypes. Unfortunately, we've added more and more archetypes over time, but we want to start making sure all these archetypes are actually supported in our Kubernetes stack. Obviously, one of the problems is we've been doing a lot of these archetypes in Salt. Salt's really great if you're trying to boot a host. You need to configure a host. You need to mutate a host. We don't want people to do that. That's kind of an implementation-specific technology. Same thing with Salt. Even writing a Kubernetes artifact is right now for us an implementation-specific technology. They're YAML files for Kubernetes, like you treat them as the assembly language of Kubernetes. This is really how the nuts and bolts connect. Most people don't want to bother. Why do I need a volume mount? Why is my secret here? Why do I need pods? What's a deployment? What's a replica set? So on and so forth. So really one of our challenges ahead is to make sure we can actually make every archetype we have, which is, Python web service, a queue worker, a streaming worker, handlers, cron jobs. Like our cron job solution today is honestly pretty terrible. You boot a special singleton, you install cron, and run some things. It's cron. And when the singleton goes away, it may get replaced, but you have some outage while you have no crons. As these systems mature, you really need to make sure you also have escape hatches. If you have a complete platform as a service, some people get very frustrated, like, I want to advance the state of your platform, but if there's no escape hatch for me to do so, you still need to give them a way out. It should be kind of a little checked. We trust you to make good calls. If you need to just go do something special, you need to talk to the Kubernetes API directly, you should be empowered to do so. Please check with us, kind of thing. One of our other uses of Salt is a lot of our permission model is based on AWS, IAM, talk to a particular resource. This even includes secret management through Confidant. You have to have a role to talk to Confidant. Right now, like writing IAM policies and all the variants, like how do I access S3 with this Dynamo table? Like, it's a little too verbose, and that's a place we also want to reinvest a lot. How do we make the basic patterns super easy, not end up with tons of copy pasta that drifts over time because people have found different patterns? Talk a little bit about Kubernetes at Lyft. We definitely need to run multiple clusters. We have definitely the need for more than 5,000 nodes, even on the largest size. A lot of our batch workloads definitely get to that place. Some companies definitely go down the approach of like, we have one cluster. The problem is you have one cluster and then you can't do anything with that cluster. You don't trust it. It's just there. Like you don't poke it. Don't taunt the cluster. It'll just break. And there's been some horror stories circling on the internet of people that have had this problem. Like, we have the big cluster. It's like, don't do that. We want to treat clusters as disposable. No single point of failure. Granted, we could probably wipe out multiple clusters with the same kind of workload, and that breaks everything. Different problems, but we don't have infrastructure problems dealing with this. Our clusters are segregated by availability zones, regions, and workloads. If you're batch streaming compute, you end up on a different cluster. If you're an infrastructure cluster, you end up on a different cluster. Clusters, like, we can spawn a new cluster in about 10 minutes. We have a Terraform stack that can do that. Due to our experiences of Docker, we actually use Cryo on Kubernetes. It's a little non-traditional. I've had to upstream some patches. I won't say it's like works super great out of the park. It's actually gotten a lot better. It's a CRI daemon, runs the same images. It's just not Docker. There's no daemon. Everything's just independently namespaced. One big thing we know we needed was very low overhead networking. We do a lot of very fast, small networking calls over and over. Large Redis clusters that deal with a lot of global states. We'd have to do things very fast. Normally, large deployments of Kubernetes and Amazon were entirely predicated on having overlay networks, Calico, Flannel, Thilk. We developed an IPVLAN plugin for CNI plugin that basically bridges a pod, gives you a direct IP in the namespace. Amazon actually beat us like announcing this by a week, but ours uses IPVLAN. It's a little lower overhead than the route table one Amazon actually has. I know a couple companies have actually started using it. Some good upstream contributions from it, so it's definitely an active development. Services also span multiple or all clusters, quote unquote. They won't actually be all. And most importantly, part of this talk is base components. The base components really decompose into containers in a pod. Because we had single tenant, all the container or daemons, envoy stats that were previously running were really namespaced to that service or that auto-scaling group or whatever the actual like coordinates were. So we want to maintain that. So we don't want to run daemon sets that just do stats. We want to actually co-locate these things with the service. It's the fastest and best way to provide isolation. We're in a state right now where we can do deployments of Kubernetes for services. We enable them via config in our nfs.yaml. Here's a terrible diagram, by the way. Don't worry about not reading anything because it's kind of boring. And actually, you really don't want to know how this works. It's blow up of this Jenkins job. Does way too much stuff. We then generate the Kubernetes manifest from the config that you kind of specify, which is containers, hosts, what to mount, what the size are, produces a bunch of things. Because we have multiple clusters, we need to find what clusters to deploy to. We've written a custom CRD for controller that looks in S3. Is there a cluster there? Is it in the ready state? Populates a list. We can ask any of the Kubernetes clusters, what are all your peers? They say, here's my peer. We actually embrace the Kubernetes concept of labels and taints. So we can taint a cluster. This is only infrastructure. This is only batch workload. We can label them for particular uses, staging, production, so on and so forth. We apply everything to all the clusters, basically a giant for loop, and then give you the green, everything's great indicator after we check that everything converged. One interesting side effect of this is part of this generation, we have not actually put in Envoy. We have not put in the stats container. Logging is actually a daemon set for us, mainly because system logs have to come out too. We have not put in our analytics queue, and I'll get into that in a little bit. Sidecars, this is where Envoy and stats would sit. For an application developer, they really say, I want to send stats. Or in the case of Envoy, I need to talk to another service. That's really all they care about. It's a service, it's kind of like a substrate thing, right? They include the Envoy library, they say, I want to talk to Envoy, or I really want to talk to users. They don't care how that happens. Some people do, most people don't. However, the infrastructure developers, you're on the networking team at Lyft, you want to deploy Envoy. And you update Envoy, you want to get Envoy out. Maybe there's a critical bug, maybe there's a security patch, or maybe it's just incremental improvements to the system. But at the same time, you don't want someone to have an Envoy from 4 months ago, because this does happen. There are services that deprecate or not important, or no one cares about them, but they're fine. At the same time, you don't want the liability of this huge version drift across your infrastructure. So what we've done so far is we have effectively the mutating webhooks in Kubernetes. So there's something you can basically hook into the API server. So Kubernetes, for super, super fast primer, as an API server, everything goes through it. The API server can now delegate things to other things, including a service inside Kubernetes, which is the mutating webhook server. Istio actually uses this approach as well. They started with initializers as well. I will mention initializers were an initial approach to this. They're not very good. There's a lot of caveats to them, and there are proposals to remove them. So mutating webhooks are kind of the future. So whenever Kubernetes schedules a pod, it calls a webhook saying, I'm creating a new object. We jam containers in it. Envoy, so on. Here's a kind of terrible example of a configuration. We can say, hey, you're injecting Envoy. Look in this config map for what version you should be putting into it. Here's some annotations that you can actually reference to say, should I be adding this or not? And it consults a config map to actually do the work. It also doubles as a validation webhook, because validation webhooks can do a lot of extra work. You can say, I don't trust people to run as roots, have host network, break the cluster in other ways. We can kind of do some selective filtering at that stage. Of course, the webhook only applies to new objects. And at the same time, we don't want to wait weeks for things to roll out. In our beautiful future world, we anticipate like nodes might only live a couple days, maybe a couple weeks most if they're a static workload. We want to be able to bound the timeline of an actual AWS instance, but that might be too slow. If you need to roll out Envoy yesterday because of a critical bug, you need to roll them out. Problem is you can't just go reach inside a pod and say, replace Envoy. Replace the SHA, pretend nothing happened, hot restart. Kind of A doesn't allow it. There's ways you could do it. You don't want to do it. It also creates a hot restart problem because when you do that, all of a sudden Envoy goes away. It's a different life cycle in the application. The application was making calls out, all of a sudden can't do that. It errors out. Kind of a giant mess. We want to have one path how everything updates. So what it really turns into is we basically need to restart all of Lyft. We do this today for services, for Envoy itself. And Envoy will actually go through a hot restart process in every host. That normally works, but sometimes you have to do a cold restart process because the Envoy stats namespace changes. There's a couple of reasons that goes to this. It's a lot of investment to keep that technology alive if you just want to actually focus on getting all the cold restarts working correctly. So what we do in the Kubernetes controllers, after we've updated, done the sidecar deploy, there's a controller that runs saying, I looked at the config map, it's version X, list all the pods, version Y. I'm just going to start deleting them. One by one, wax a pod, controller, that normal deployment controller comes up, recreates the pod. And application's the same version, that's immutable, that container's immutable, but now it has a new Envoy. Obviously, this is dangerous, but it is kind of chaos engineering because you're refreshing your infrastructure at a pretty rapid pace to do this. You need to monitor the system. You need to say, hey, is everything actually recreating correctly? Are things starting? Are we not dropping capacity to 0? Have we not broken all of Lyft all of a sudden? So that's part of the control loop that says, hey, this has happened. We also can update the webhook saying, stop rolling out new things. So if you recreate things, you need to actually re-inject the old version because you're still in the active injection path. We also definitely didn't want to mutate the deployment, which is, put the containers right as the deployment's created. There's lifecycle problems. People deploy while Envoy's deploying. We want that to work. It's very confusing. You have to wait for Envoy to roll for your service while your deployment's rolling. By having them separated, we can also optionally not do this. There are certain cases where when we do a rollout, we're okay for a couple of days. If nodes turn out, pods get deleted, so on and so forth. So we wanted to maintain that flexibility. We actually work all the way at the pod level. There's a couple things we definitely don't do yet. For instance, we're definitely doing all the deployment objects of rolling updates. We want to get to a state where we're actually doing blue-green deploys on the system. Previously, we've hot restarted, so we've kind of worked a way out of this problem by just being able to hot restart code. The problem is you have models. Models take a while to load. Models take a while to download. You have gigabytes more of data you need to basically bootstrap into a system in order to make it work. Or you have like stateful service, like you're running Elasticsearch in the system. It doesn't start instantly. It takes a while to think what it's doing and get to a good space. Blue-green deploys let you have old and new and then do traffic routing. So we need to actually get to a state where we're actually having those control loops. We haven't done development in this direction yet, except for prototypes. But getting Envoy for like a CRD, which mirrors a deployment for blue-green. So we can actually crawl into our control plane saying, shift traffic away or two. Multi-region support, haven't really done that yet. Spoiler alert, we're in one region. We also want to get to finer grained deployment and rollout stories, which is how we do shadows, baby versioning. Right now, our current system is very limited to you will deploy your entire code. Your Git repo will be deployed to an environment. There's no way to split that. We want to get to a good state. We also want to get to better visualizations in front end. This is a place that I feel is really lacking in this area. There's technologies that do kind of bridge into the system that hook things up. Kubernetes dashboard is actually not terrible. The problem is it only works for one cluster. If you have to tell people, you look at these 4 dashboards and to figure out what your service is doing, that kind of sucks. We need to provide a good visualization that replaces the Jenkins workflow, adds a lot more context, be able to give people that data. And finally, we are also expanding the deploys team in New York City. So if any of this sounds in any way interesting, please join us. I'll leave this up for a bit. There's the happy hour. When is this, Friday? Yes, Friday. Days. And we also have flyers floating around. If you need a reminder of where it is, there's one up here. They look like this. And thank you all. And it's time for questions.
So for questions, I have a mic. If you've got a question, just raise your hand.
So earlier you said you guys using the deployment object or replica sets when you guys, because you said rollout and that's like a deployment construct.
That's a deployment construct. Yeah, we're using deployment objects for just letting them do the rollout, let them manage the actual lifecycle. For the blue-green or other deployments, we effectively do the same thing with those 2 replica sets and let it do our own control loop for rollout. That's something that doesn't quite exist in the ecosystem yet.
I have 2 questions. The first one is that you mentioned that you guys did a recent upgrade for to the C5 instance type, right? So how did that go?
Sure. Yeah, so C5 has been pretty good. We've been doing it pretty slowly. We found a bunch of issues with it, and we've been working pretty closely with AWS to report all the issues we've been seeing. And they've been really good with us so far about giving us a lot of information about the fixes that they're putting into place for those. And I think it's only pretty recently that I've felt personally more comfortable to start rolling out C5 en masse. And so we're probably like 60-ish% of the way through a migration for all of our compute workload over to C5.
Okay. And another thing is pretty related to what kind of a networking interface do you guys use?
Sorry, could you repeat the question?
CNI.
Yeah, so our networking stack is, we wrote our own plugin. So what it does is it basically goes to AWS and says, give me another ENI adapter. You can attach multiple adapters to a host. And then it says, give me multiple IP addresses. You can have varying amounts depending on the size of the instance. Like I think the largest instance types, like you have 8 adapters of 30 instances each or something crazy. That's not particularly, like that scale isn't particularly useful. Once you get to 100, that's good. So what we do with the adapter, with the CNI plugin, is it creates one of those, make sure there's an IP, it actually maintains a host cache of them, because calling the VPC stuff tends to not, it's a pretty slow API. So we have caches on every host for the last unused IP. And then we put the IP into the namespace and an IP VLAN interface directly connected. So the upside is it's as direct as we can get from the host networking stack. There's no host transit, like host IP tables rules don't even apply. There's another like channel out for the default addresses, which goes to the host if you want to use service IPs in Kubernetes. Where most of our workloads, we use Envoy direct point to point, so we don't actually use the service IPs or anything in Kubernetes. So that path is not as much used as the direct point to point, which is all IP VLAN to an ENI adapter direct.
Sure. With the move to, with the move to Kubernetes, did you guys change your developer workflow at all? Are you using anything like telepresence, or are you still using that one Lyft setup?
So that's definitely in the works. We've in the past tried like offload systems where you could have, we do have a VM on the laptops that people can use. Way back in the day, you could probably run Lyft on it. They stopped selling MacBooks with more RAM, so you can't actually do that anymore. It takes probably 40 plus services to do that correctly now, and that doesn't fit. We've definitely toyed with that idea. I don't think with offload, there was a number of bad call patterns related to how we're doing in networking that just made it completely unusable for most people. We are putting we're pivoting between Minikube and like Docker for Mac and finding that path flow, but we do have a developer tool called Control, which is being taught how to talk to Kubernetes and spawn containers. So that becomes the same. And eventually we can move to that one box effectively being fully distributed. Instead of one instance, you need to share parts of it, but that sits entirely in AWS.
We have some questions from downstairs.
Leave it.
Are you guys speaking? We can't hear you. Try it again. You guys are muted on the screen down there.
There we go.
There you go.
Okay, can you hear us now?
Yes.
Okay, cool. I have a question. What do you guys do for the settings, or how do you version, backup, config maps?
The actual config maps, so for the most part, like, we've been putting configuration, Gear can talk a little bit about runtime. We've had kind of this weird central place for configuration, so applications haven't necessarily shipped with configuration. That said, our plan, if we do introduce config maps, effectively becomes pinned to the SHA of whatever built the config map. So all of our container versioning is literally one-to-one. It's tagged to here's the SHA of Git, here's the SHA of the container. Some people, like 1.02. We version libraries that way, and then eventually your library version is electronically increasing numbers. It doesn't really matter too much. We'll definitely see the value in having the Git history displayed. So the second you introduce a second version number on top of that, unless you're very diligent about creating releases, it doesn't really make much sense. We want to get also to a world. That said, like we do get deployments and we actually branch them too. So you need the SHA to actually identify what point that was. If hot fixes need to back off somewhere.
So right now the settings are shipped inside of the container? Sorry, I didn't get that.
Yes, for most services, they are actually inside the container. If there are settings, it's actually a centralized repo, which ships everywhere at ever-increasing pace. If you want to learn more about that or why that's a problem, I can hand it over to Gary.
Yeah. Okay, thank you.
How are you guys planning to handle persistent storage databases? Are you planning to move that in? Which volume drivers?
That's a good question. Lyft has traditionally completely avoided running databases ourselves. Our largest database is probably our Elasticsearch instance we use for log search. That becomes, SSDs, i3 instance types, get that as fast as possible because otherwise Elasticsearch becomes very sad. That's not a particular one we've wanted to migrate yet, but it should be pretty possible if we pin to nodes, just use the ephemeral storage. We're doing replicas. Our logs are entirely in S3 first. So if we actually have data loss, we just have to replay, which does suck, but it is possible to do. For our other workloads, we've had a couple people using, like for instance, we have an in-cluster monitor, which is actually Prometheus, and we just put that on EBS volume. GP2 bound to node works fine. It doesn't move much. Obviously, unmounting and remounting EBS volumes can be a little hairy and then stick and then break, and then you have to go intervene, and then your cluster monitoring is down while you're stuck. It's unfortunately an AWS problem right now. We have one other person actually for our machine learning workloads trying EFS and doing mounts of that. All the joys of NFS, which there's none. So I don't want to recommend that, but it does work somewhat.
How did you optimize your bake-in periods so you could actually get some useful information from that? And do you still use that with Kubernetes?
Because you probably do most of the bake.
Yeah, so deployment baking in particular?
Yes.
Yeah, so like in general, we don't mandate a whole lot from an infrastructure team at Lyft. We really try to provide guidelines and then sort of empower people to do what they need to do. So we really don't force anybody. Like if you really want to, you don't have to bake it all. You can just go blow through the whole pipeline, go directly to production, maybe take down everything, maybe just get on with your day, who knows. So there's nothing to stop you doing that, but so far what we've done is, I think it was in the previous slide, but we put a little light on the Jenkins pipeline. And this is a terrible JavaScript hack in the Jenkins plugin that exists. But we basically just give this little light that says, has it been 8 minutes since the deploy hit the environment? And to us, 8 minutes is the time it takes for sort of all of the stats to flow through and alarm thresholds to trigger. And so we feel pretty confident that after 8 minutes, if you broke something, you should have an alarm, unless you don't have an alarm. So hopefully you've set good alarms up. And we try to just encourage people to take it slow and really do those kinds of things. But it's something definitely that we've found difficult. I mean, the more environments and the more stages you add to a deploy, the longer it takes someone to do a deploy. So you times 8 minutes by each segment of an environment. And so we really want to get away from the whole like 4-step production deploy and move more to a you click one button to go to production, and then we have automated health checks, and we can just slowly start to go to production. And it's more of a hands-off process rather than a, like watching graphs, clicking a next button kind of deal. Just to give time back to people that are spending a lot of time clicking on Jenkins UIs.
Just are you guys using Prometheus for that tooling for that visibility into it, or what are you guys using?
For alarms and things like that. So we don't use Prometheus. Today we use Kibana and Grafana pretty heavily. So we have our own version of that internally. We use a tool called Wavefront for stats as well.
Okay, we have a question here in the room.
What is your strategy for upgrading the clusters themselves?
Effectively, minor point releases, we can just roll nodes in. If you're talking about like a 1.9, 1.10, 1.10, 1.11, those kind of major bumps, we stand up a new cluster because they're not particularly special. And if we have more than one in an environment, we can start draining one and move everything to the other as a validation test. Because things do break, workloads go weird. We want to wait a couple dot releases before jumping on a new release because that's when everyone finds all the actual bugs before the RC period. But yeah, we stand up a new one with the new version, let workloads migrate to it as they deploy, or force them to migrate over if we don't want to wait too long. Mark the other one as a draining cluster, so anything that's actually in it will eventually just drain out and go to zero, and we repeat that for every environment we have.
Thank you.
Ew, me again.
Hi.
So earlier, guys, you talked about your IAM policies for your instance profiles. So are you guys using, well, it's two questions. A, are you using kubeIAM? And B, if you are, do you guys enjoy it?
We are using it just because it does work. We actually have another project called metadata proxy. If you look at our GitHub, which is a prior version of this that worked with our other environments, our traditional Docker environments. It has not been necessarily been fully problem-free, but it has actually worked well enough. There are some issues with the nodes become very all-trusting. We actually might want to move away from that model and just somehow locally inject secrets for their rotating IAM credentials. We haven't fully settled on that. We do notice that some services have really bad call patterns in terms of IAM, where they'll just hammer the metadata proxy like on every request to get more credentials. So that doesn't scale well, and we might actually have to do some modifications in that stack instead of fixing every bad service and library.
Where do you keep the metadata for all the various services? Because Kubernetes itself seems to be almost like temporary storage for just what happens to be running right now. But then you decide which cluster any workload lives in. And if you rebooted everything, which of the 500 out of however many Git repos you have actually have services that need to be deployed?
So we have this thing, it's called the aggregated manifest. We put all the manifests when we build an image into S3. So mark this SHA, it was this. As we actually move through the lifecycle, we mark another file in S3 saying this is production, this is not. We're going to have to extend this model a bit with Kubernetes, especially we have more diverse rollouts. But we were able to actually go to S3 and just iterate everything that's currently in a particular state, and these are our markers. It's similar to how the pull deploy model works, just mirrored for containers. It's something we built way before Kubernetes, and we're kind of reusing that technology stack.
So then does each person who owns an S3 config decide which cluster their workload goes in, or you have some sort of external?
So by default, the service wouldn't pick. They would just get blanket applied to whatever the environment is, say staging, across every cluster in that space. As we add a new one, we'd obviously have to go reconcile what's missing in one versus the other. I won't say we're experts at that yet. We haven't really built that tooling out.
I guess if no one else is, have blobs for the configuration worked well? Like, do you have the need to query against all of your servers to find similarities, or say find all my whatever language it is and make sure the runtime's up to snuff?
Yeah, it actually has worked really well. There's a lot of tools built on that giant blob of JSON, which is merged together from everyone else's YAML, which turned into JSON. For instance, all of our monitoring tools are built on that. We can generate alarms for everything depending on what state it is. look at the file, loop through everything as a giant for loop, blanket apply. We do the same thing with container base updates. So if we need updates, your pin, your Docker file base. One thing I didn't mention in this, we're actually trying to slowly back away from Docker files and get to something like source to image, which has a little more declarative structure where you can build an application and then transplant the contents onto another container. It's still a container image. It's still a repeatable image, but it reduces the need to write Docker files, which are kind of the assembly language of service building versus the assembly language of operations for Kubernetes YAML. Thank you.
More questions? No.
Question here in the room.
Hey, question from downstairs. What do you mean by that? Can you elaborate? When you say do away with Docker files and bake the application into a container, that makes a presumption of dependencies that are already on the image, doesn't it?
Yes. One thing we're looking at, if you look at, Docker file is multi-stage builds. They're still a very, line by line interpretive structure, what to do if it's all the sequencing. Source to image is something like Red Hat, OpenShift has played around with, which is you have a builder image and you have a runtime image. Because the reality is, in order to build an application, you need to have this particular stack. In order to run an application, you don't need that stack. So outside of the Docker ecosystem, it lets you basically have a way to build an application, produce artifacts that then get transplanted into another image as this is just the runtime for it. Obviously, there's strong coupling between the two, because if you have a library installed in both, but the other version doesn't need like the headers installed. Multi-stage builds are another way to approach this, but it's step by step, a little harder to sequence. Ideally, when a Lyft service developer says, I want to create a Python application, they write some Python, they put their requirements, text or unpinned requirements in the thing, and it says build. The fact that there's a Docker file, there's a from, there's do all these steps is mostly hidden. Obviously, escape hatches are needed, but the idea is to get as declarative as possible for the archetype we have.
Cool. Thanks.
You mentioned about cryo and obviously the source to image piece about open. Have you guys looked at OpenShift at all versus raw Kubernetes?
Yeah, we have. OpenShift has been historically everywhere. They've kind of rewritten it a couple times as they figured out what to do. It's probably on a better track. Some of the technologies we're using, like the mutating webhooks, OpenShift really tried piloting as we need this capability in a cluster, and now it's definitely part of upstream. We haven't wanted to jump in fully on there. It's probably, we need to get to an incremental approach. OpenShift is if you're starting from the ground up, it might be interesting. I can't say we've fully evaluated it from all the things that are wrong or right with it. It's not a slam dunk, but it is starting to look like an interesting solution in the space if you're looking for a more high level workflow. Repos, builds, everything's kind of automated already.
Last questions going once, twice. Okay, well, so big thanks to the Lyft folks for talking to us through their deploy infrastructure. Just a quick reminder before we go, we have our next meetup June 7th. It's more Kubernetes, CI/CD. This time Oracle will be speaking about their journey as well. So again, big thanks to the Lyft Deploy Tools team. Thanks.